Hello, we're back with another video here on financial economics and arbitrage theory. Um, this one's going to be kind of fun. We're going to talk about indifference surfaces in a two asset, two state market. Okay, so we're in GeoGebra, we'll hit start calculator, and we'll go ahead and do a 3D calculator. So in this one, we're going to go back to our other notation in which all of these are cash flows. So a positive price that you're paying is now a negative cash flow, so it's going downward, okay? So let's go ahead and put our standard asset in of putting money under the pillow. It's going to pay off $1 in every state, but it takes a negative cash flow today. You have to get rid of your dollar, okay? So that is going into the plane, so it's under there, down there, okay? So that's putting money under the pillow. And let's go ahead and put in one more just standard asset. Let's do a bet that you lose $1 in the bad state, you get $1 in the good state, and it costs you no dollars today. Okay? So here we've got two pretty standard assets. Let's go ahead and let's draw a plane through these. So here, here, and here. Alrighty, now we already have our market. And you can see we're used to it going upward over here, but it's going downward this time. And the reason that's correct and arbitrage free is because our notation switch and now we have cash flows instead of prices. Okay? So this is looking good. Alright, and the next thing we want to do is think about our indifference surfaces. So now if you remember in 2D, we had indifference curves, right? So when we just had one state in the future and we just had cash flow today, cash flow tomorrow, we had these curves that looked along here that we were indifferent among, right? And so let me come over here and we'll write a little bit. Okay, so we had a utility function, and it used to be it was the square root of x times y, where x was the price in the future and y was the price today, or cash flows, right? And then we squared both sides, so we had u squared is equal to xy, and then we divided both sides by x, and we had u squared over x is equal to y, right? So that was our utility function in 2D. So now in 3D, we're just going to put in one more variable. So we're going to have x, y, and z. Okay, and then we're going to do the same thing. We're going to have u squared is equal to x, y, z. And then this time we want z by itself. So we're going to do z, I just dividing and then moving the sides, is equal to u squared over x, y. Okay? Okay, so we are trying to graph this function. Okay, so we'll come over here to GeoGebra, and what we'll do is we'll make some u, alright, and it's some value here. Utility can't be negative in our case, so I'm going to minimize that at 0. Okay, and what we want to do is we want some function called u squared, okay? And then we want to divide by x times y. All right. Oh gosh. Okay, so we've got a lot going on here. So we've got, this is actually the one we want in this quadrant, and we've got a lot over here. So here's what we'll do. We'll take basically this same thing here. So I'm just going to copy this. Let's see if that copying works out for me. Actually, what we'll do is we'll just put it inside. Okay. So we're going to do an if statement. We're going to do if x is greater than 0, and I just did the ampersand twice, and y is greater than 0, then this is what we want. Otherwise, we're just going to put in like -10 to just get it off the page. And there we go. Okay, so now we've got our function here, and the rest of this stuff that would be around here is just off the page. Okay, so now we can slide this bar, and you can see it's moving up and to the right there. Okay, so these are lines, or these are surfaces of constant utility. So at 5, it's way up there, right? So this means, you know, you've got some really good payoffs here, right? So really good payoffs on all of these cases, right? So a payoff of +5, payoff of +5, payoff of +5. Remember, this is cash flow now, not price. So all of these are super good. That's why you get a ton of utility from this state. Okay? So let's bring it on down a little bit, but no big deal. All right, so let's do something here. So let's say, remember what we did last time is we said, okay, well this right here is the market. This is what we can trade on. And you can probably see where I'm going with this. Let's say you initially had maybe $4 to start with, right? So okay, so let's say we start with $4, right? And we want to move this plane up to where it intersects at 4, so 4 is sort of your do nothing scenario. And then you can trade along this plane, right? So how we're going to do that is we're just going to move all 3 of these points upward. So what I'm going to do is I'm going to make a vector. Make sure you put 2 parentheses in there because the argument to a vector is a point. So we'll do 0, 0, 4. Okay, so that's this tall vector. And I'll go ahead and hide it, but we're going to use it algebraically, okay? So I'm going to add that vector to all of these points. So let's do a plus v, okay? Let's do b plus v, and let's do c plus v. Okay, so now these 3 points are just these 3 points shifted upward. And let's draw a surface through those points. Voila. Okay. So now I'll actually go back and hide our original plane. So this is the plane we're working with now. And you can see we actually pretty much nailed it without even intending to. So what that means is, see, it's intersecting here. So what that means is if we started off with $4 and we're allowed to trade along this on this market, then we're going to end up with about 2.9 utility. So for example, if we come higher, you see it's not intersecting. So we can't get a utility as high as 4.3. And if we come too low, we can do better than that, okay? So let's just move this up along here, right? And again, about 3, 2.8, something like that. And of course, if we just moved this vector and we made it not quite as tall, so if we said, okay, we only started out with $2, okay, well now what utility can we achieve? And you can see we have to go down more, and that looks about right. So we can only get 1 utility if we start out with $2. Yeah. So this is just a nice way to visualize, and actually more than that, you can see the point of intersection. This is the asset you want to go for, right? You want this asset that gets us about $1 in each state. Yeah. And we can actually, I was going to say we could do it, but the problem is we're going to have a little bit more than 1 intersection. We can probably make ourselves something though. Let's just go ahead and say, all right, this point right here on the plane, actually D is pretty darn good. So let's just use D. So D, where is D? D is just 1, 1, 1, and that's exactly what we said, right? So the payoff we're getting is 1, 1, and then 1 as well. So it's 1 in every state, and that's how we're getting 1 utility. All right, so basically that's like having $2 and then trading off putting $1 under your bed, right? And then you know you get $1 in the future, no matter what's the situation, and then you also have $1 today. And that actually makes sense because our utility function, it didn't treat X, Y, and Z differently, right? So now in this case, our optimal scenario is when they're all 1, 1, 1. That actually makes a lot of sense. There's maybe another way to think about this as well. So what we talked about here was, you know, if you've got a certain amount of money, so let's say in this example $2 in your current state, and you have no investments or anything, this is what you would do, right? You would put $1 under your mattress, and then, you know, so that's sort of investing. So you save $1, and then in the future, you know you're going to get $1, whether good or bad, but you have $1 fewer to consume now. Okay. So another thing we could do is, instead of saying, okay, we start off at $2, let's say we start off at $0, but you've got a buddy who says, all right, well, if the good state happens, for example, if the stock market goes up, I'll give you $5, and if it goes down, I won't give you anything. Okay, so what that's equivalent to saying is, oh, well, your starting point is no longer, you have $0 now, so that's 0. But your buddy told you he's going to give you $5 in the good state and 0 in the bad state. So I'm just taking this vector and I'm moving all of our sort of baseline points over here now, right? So all of our kind of starting values are over here, right? And that's what we're going to start with, right? But these same assets still apply, right? There's still the option to put money under your mattress, and there's still the option to take a bet where you win $1 or you lose $1, right? So those assets still apply over here, right? But the thing is, we've moved a little bit, right? So since you have $1 or $5 in the future in the good state, that means, we're going to have to move this utility surface a little bit until it intersects. Boom. I think it intersects about right there. What is that? That look pretty good. Yeah. And so now our utility in this situation is 1.5. And what would we do to get there? Well, it's a little bit harder to see this time. So we start here, right? And we end up at the point where this intersects, right? So it's about right there, okay? About right here. And so how do we get there? Well, this is taking a bet of the good, winning in the good state and losing in the bad state. What we could do is reverse the bet and take the other side of it and say like, oh, well, I'll take $1 in the bad state and you get $1 in the good state, right? So that's going to bring you over here. So you just have to do that a time and a half, right? Or 2.5 times, and that's going to get you right here. And we want to do the opposite of putting money under your mattress. So what is that? That's borrowing money today, knowing that you'll have to pay it back tomorrow. So if you borrow $1 today, then that will get you about right here at that intersection point. So you take -2.5 of the bets, you borrow $1 today, knowing that you'll have to give it back tomorrow, and that gets you to this intersection point, right? And so that's how you get your maximum utility in this case. So basically what it boils down to is, given different situations and given different markets, how high can you get your utility? And that's really the name of the game. So thank you. I hope that was interesting.